Hello students, H2O between 0 to 4 degrees Celsius. So what really happening between 0 to 4 degrees Celsius for H2O? We know that H2O melting point, ice melting point is 0 degrees Celsius and its boiling point is 100 degrees Celsius. But what is the speciality about this temperature range which is 0 to 4 degree Celsius? What is really happening there? Something which is happening unexpected. That's why it is called as anomalous behavior of water, or anomalous expansion of water, or anomalous contraction of water. So what happens at this temperature range? Let's find out. Let's have a look about the three physical states of matter. One is the solid, liquid and gas. So let's say this is a solid form of water which is called as ice. This is a liquid form which is water, and this is the gas which is called as vapor. So how ice changes into liquid water? When we provide the temperature. That means when we heat this ice, what happens, students? The molecules here, each circle indicates a molecule of water, molecule of H2O. So here all these molecules, when we provide the temperature, these molecules get rid of these intermolecular forces of attractions and they try to expand. More temperature, more expansion. So that is what happening from ice to water, water to vapor. What is really changing? Is the molecule changing? Are the molecules all changing? No, the molecules are not changing. Still the formula of water is H2O, ice H2O, vapor is H2O. Then what is changing? Intermolecular forces of attractions are changing. Intermolecular spaces are increasing. Why? Because of energy. So when we provide this energy, what happens? The molecules gains energy and they try to expand. More energy, more expansion. So that's why the melting point of ice is 0 degrees Celsius. The boiling point of water is 100 degrees Celsius. So that means at 0 degrees Celsius, ice starts melting. It converts from solid form to the liquid form. And at 100 degrees Celsius, liquid water converts into vapor. So what about the opposite process? That means how to convert a vapor into the liquid form. So students, here we need to reduce the temperature. That means we need to cool. When we cool down this, all the molecules try to contract, they lose energy and they try to absorb in a very less space. They started developing the intermolecular force of attractions are getting very stronger. So they convert into liquid. And how to convert liquid into ice? Again by cooling. So by cooling, all the liquid molecules will segregate each other, one another, and they form strong intermolecular force of attractions and they become into ice. So to convert ice to water, the temperature is 0 degrees Celsius, which is called as melting point of ice. But how to convert water into ice? What's the temperature? The same temperature. Yes, at 0 degrees Celsius, the solid form of H2O and the liquid form of H2O are in dynamic equilibrium with each other, which means ice converts into water, water converts into ice at 0 degrees Celsius. If you increase the temperature from 0 degree, it converts into water. If you decrease the temperature from 0 degree, it converts into ice. This is clear. This is how the physical states are changing by changing the temperature range. Which is more dense, ice, water or vapor? Density means mass per unit volume is called as density. That means number of molecules per unit space is called as density. So where there are more molecules per unit space? Here, here or here. Clearly ice is more denser than water and water is more denser than vapor. Means when we change from ice to water, density is getting decreased, and water to vapor, density is even more decreased. And in the opposite process, vapor to water, density increases, and water to ice, density increases. Clearly, if we increase in the temperature, density decreases. If we decrease in the temperature, density increases. Clear? That is what the normal behavior. But for water, which is H2O, between 0 to 4 degrees Celsius, 0 to 4 degrees Celsius means temperature is getting increased or decreased. 0 to 4 degree means temperature is increasing. 0 to 1 degree, 2 degree, 3 degree and 4 degree. Between this temperature range, when we increase the temperature from 0 to 4 degrees Celsius, the density of H2O is increasing. It should decrease, right? If the temperature is increasing, the molecules are expanding, the density should decrease. But between 0 to 4 degrees Celsius, the density is increasing. That is the anomalous behavior. And one more thing, students, clearly you can see between ice to water, that means by the change in the temperature, what happens to the volume? The volume is getting increased or not? Ice to water. Why? Because the molecules are occupying more space. But between 0 to 4 degrees Celsius, the volume is decreasing. So this is called as anomalous behavior of water. So that's why ice is more dense, right? In general, ice is more dense. If it is more dense, it should sink in water, yes or no? But why ice is floating on water? That is what the anomalous behavior is about. Let's find out what is really happening at the molecular level between this temperature range. So ultimately, all this behavior, anomalous behavior, is because of molecular arrangement. So have a look about the water molecules, like how the H2O molecules are arranged in all the three physical states of matter: ice, water and vapor. So look at the H2O molecules in vapor, right? So there is a big space between the H2O molecule and the H2O molecule, right? That's what the vapor is. Because of more energy, least intermolecular force of attraction. You can see these dotted lines indicate the force of attractions are there, but they're very least. And look at the water, H2O, liquid water. So the molecules of H2O are clearly segregated with each other, so they develop stronger forces of attractions. So that's why when we compare between vapor and water, they are a little bit closer enough. Yes or no? The density is getting increased. Now look at from water to ice. So what happens, students, here? For the H2O molecules arrangement in water, and look at the H2O molecules arrangement in ice. So what happens? They should even more contract, yes or no? But you can see there is a clear expansion. Why it happens? What is the reason for this expansion? The reason is H2O molecules, when you reduce the temperature, they develop a special type of bonding called as hydrogen bonding. So that doesn't mean hydrogen bonding is absent in these two states. Hydrogen bonding is there, but what really happening here is there is no energy. The energy is very less, and they develop hydrogen bonding very stronger. So because of this strong hydrogen bonding, these H2O molecules form a separate alignment that gives a lot of empty spaces between the water H2O molecules. But here, look at, are there any big empty spaces here? No. Why? There is hydrogen bonding here, but still there is some energy here. There is no perfect alignment of H2O molecules are there here. But when you reduce the temperature, now there is least energy and hydrogen bonding that creates a perfect structural arrangement of H2O molecules in the ice. So that's why these spaces are the reason why the density is getting decreased. The density should increase, right? But the density is getting decreased. Where there are more molecules per unit space, here or here? In water only, there are more molecules. Why the density is getting decreased? The molecules are perfectly aligned because of hydrogen bonding. Because of this hydrogen bonding, these H2O molecules cannot come closer. Why? Because not only attractions, there are also repulsions. But to overcome these repulsions, there is no energy. Here there is more energy in water. Now, one more thing. What is this anomalous expansion and anomalous contraction? Students, listen here. When we provide the temperature from 0 degrees Celsius to 4 degrees Celsius, that means we are increasing the temperature or not? If we increase the temperature, what I said? The molecules will expand. Why the molecules will expand? They get rid of the intermolecular force of attractions, they gain the temperature, and they occupy more space, right? This is what the real behavior is. But from 0 degrees Celsius, when we increase the temperature, first what happens? These intermolecular force of attractions will break. If the intermolecular force of attractions will break, then what happens to these H2 molecules? They will expand, right? Yes, right. But before the expansion, there is a lot of empty space between the H2O molecules in ice. Yes or no? Initially, these H2O molecules between 0 to 4 degrees Celsius, they occupy this space. All these H2O molecules occupy this empty space. If the H2O molecules are occupying this empty space, now are they expanding or contracting? They're contracting. Why? Because there are already empty spaces created, and the H2O molecules are trying to occupy those empty spaces. So that's why initially the density is increasing, and from here if you increase the temperature to 4 degree, like 5 degree, 6 degree, 10 degree, the molecules will expand. That is a normal behavior only. But in the opposite process, from 4 degree to 0 degree Celsius, if we reduce the temperature, the density should increase because of stronger hydrogen bonding and the perfect alignment of H2O molecules in ice. That gives lot of empty spaces between them, and these empty spaces are the reason why there is a clear decrease in the density. That's why ice floats on water. This is the anomalous behavior of water. Students, I hope you got the clarity.